Hello, everyone, and welcome to the Weekly Space Hangout for Wednesday, December 20th, 2017. I'm Fraser Kane, publisher of Universe Today. No news this week. We're going to be doing our annual, yearly roundup of all of the big stories. We're going to properly organize them according to the laws of physics, I believe, to make sure that we have accurately ranked every important thing that's happened. We've missed none of the important news. We've gathered it all up, and we're going to talk about them here. And then we're going to fight, I think, is how this is going to play out.
Fisticuffs.
Joining me is, of course, let's start with Dr. Paul M. Sutter, the director of scientific... No, wait, you are not. You are an astrophysicist.
I just got fired.
I know you just got fired. By the way, he just got your job. He is an astrophysicist at Ohio State and the host of Ask a Spaceman, and the head of Astro Touring.
A head involved in Astrotouring. Astrotours.co. Astrotours.co.
Yeah. We've got Dr. Kimberly Cartier, Earth and Space Science reporter for EOS Magazine, and the new director of scientific presentation at the Fort Worth Museum of Science History.
I ain't moving to Texas, sorry. No. I'm content over here. Hey, guys. Welcome to the inaugural. I've been told it's inaugural and not first annual yearly roundup.
Perfect. And last but not least, Dr. Morgan Renberg, the director of scientific presentation at the Fort Worth Museum of Science and History, and also the writer for a very cool episode of SciShow Space that just came out like a day ago.
Awesome. I'm not even sure I knew.
Yeah, it was something about living on Mars.
Yeah.
That was a fun one.
Yeah.
I gotta
Great.
watch
Happy
that.
holidays, everybody.
Oh, yeah, happy holidays. Yay.
All right, so before we get into all of the properly organized and ranked things, we should just make a big quick thank you to the folks at the Weekly Space Hangout crew. Thanks, everybody. We made it through another year together. They were acting as the executive producers of this show, organizing, and I'm not kidding, all the guests. So thank you as always. And if you want to be a part of this group, just go to wshcrew.space. And that's how you be part of this chat down here. And also, you then can be an executive producer and bring in the guests that you want. We're still waiting for someone to bag Elon Musk, get him to come in here and be in the show.
Yeah, what's up, guys?
So
Just to be clear, not a physical bag.
no,
Please.
Yes.
no,
Really
Not
bad.
admin.
no.
Yeah, we tried that.
No, that is not a good move. No, just a metaphorical one. All right, well, let's get on. We've got an order here, and of course, the order is perfect. Not
Very scientific.
It's very scientific, not
Yes.
to be argued with. And so the last but not least, starting at number 10, is Paul Metzetter, the 2017 Nobel Prize.
Yeah, so every year there's a Nobel Prize, so that's not exactly news. And it just so happens this year is related to stuff in space. And this was awarded to the principal investigators, the leaders of the LIGO collaboration, who have been leading and laboring for decades until they finally nabbed one of those faint little echoes of gravitational wave.
Woohoo.
Yay!
Go gravitational waves.
Unleashing a new era in astronomy.
Now, was this the first time that a Nobel Prize had been handed out for gravitational waves? Because didn't we have a hint of them back in the day, seeing them in pulsars?
Yeah, back in my day, we've not just a hint of them. This is the second Nobel Prize awarded for gravitational waves. This is the first time there's been a direct detection, but we do have solid indirect detection where we can observe two pulsars spiraling in towards each other, and the in spiral is due to the emission of gravitational waves, and we're able to measure that in spiral, the rate of in spiral, and it exactly matched what we predicted from Einstein's relativity and those two objects emitting gravitational waves. So we've known they've been a thing since the early 90s. It was 91, 93, something like that. When that Nobel Prize was awarded.
And this is the final prediction made by Einstein, wasn't it? Of all of the, like the one that he thought that nobody would ever be able to actually directly observe and confirm. I think it was the one he thought was going to be the hardest.
Take that, Einstein.
Yeah.
Who do you think you are, Einstein?
Yeah.
Yeah, whatever.
I'm wondering if which came first, gravitational waves in terms of predictions, gravitational waves or micro lensing, or lensing in general, because Einstein, he knew that lensing would happen and that we'd see it around the sun. I don't know if he thought it could happen with extrasolar objects because that is a very, very precise measurement. But then he didn't know about galaxy clusters and how massive they are and how they can act like giant lenses and make it lensing very apparent. I don't know which one came first.
I don't know about you, but I still remember where I was when I was listening to the press conference that announced gravitational wave discovery, and I first heard like the little blips, and I was like, oh.
Really? I don't even remember what month that was.
What? It's February.
It's February. The detection was in November.
Yeah.
November of 15. And then the announcement, or October, November 15. And then the announcement was 16, February 16.
Yeah.
I'm such a bad astronomer.
We had a whole big like gathering.
That's someone else.
Yeah.
In the astronomy department. It was awesome. We had the big screen and there were cheers when the thing happened.
Yeah, it was a huge celebration, I think, around the world. Everyone was tipped off. Everyone knew this was going to be it. This was the detection of gravitational waves. And so departments across the world organized parties to watch the live announcement. And there were cheers. And I loved how they came out in the press conference. And it was like the first sentence, like, hey, everyone, we found gravitational waves.
It's
All right.
not one of those things you keep people in suspense about. No.
So coming in at number 9, and this, so is I guess, the rebanding of the National Space Council. And this is, of course, this group that was put together by George H.W. Bush back in '89. To discuss matters of spaceflight, and that it had gotten disbanded in 1993, and it was reestablished this year by the Trump administration. And the
Space Council, I think, actually goes all the way back to like the space race, right? I mean, the JFK established the space.
I think there was something
there
very
has
similar.
been, yeah.
In charge of it.
There was an original NASC, the National Aeronautic and Space Council, and that was operated until '73, and then there was it was then set aside, and then another version of it came up in the H.W. Bush presidency, and then it went to and then it was set aside in '93 and back now. And
what did they do?
Well,
Yeah, what have they
advise
Advise
the
people
administration
about
on
space.
matters of spaceflight. So, and so this one, it was a very public affair. I mean, we sort of talked about it. We talked about how there was like the Vice President Mike Pence stood in front of the space shuttle, which I keep saying that was so awesome
That space
to
shuttle's
see.
very cool.
Yeah, from this point on, I am always giving presentations in front of space shuttles. It's very
Good
impressive.
space shuttle.
But and they laid out the plans to return humans to the moon and
Instead of Mars.
Well, to the moon
just not
and
getting
then
far
to
about
Mars, but didn't provide the funding. Like, there's a whole argument that we don't need to have today, which we can have.
Dream power.
Yeah, that we can have at some point about how realistic the plans are to actually send humans to either the moon or Mars. But I do like to see this. I think it was pretty great to bring this council of people back, and it was both a lot of the old guard people from the traditional spaceflight groups, but also people from some of the new space firms like SpaceX and Blue Origin. So I think it's a great representation.
Did you get an invite?
No, well, I'm Canadian, so they wouldn't let me be there.
I mean,
Well,
I'm
you're,
just
you're,
down the
you're
road. They
capable
should've-
of giving advice. It's not
Yeah.
like you're in line for presidential succession.
It's true. Anyone who will listen, I have explained what I think is the most effective way to run a space agency. So whenever they want to talk to me, I'm ready.
They've got
provide
your
that
number.
advice. Yeah, exactly.
Launch people with a giant rubber band into space.
Trampoline, I think it was a Russian plan. But
Yeah, well, a year on, we have a space council, but still no NASA administrator. And there's never in
Yeah.
NASA's
So now
history
we got
has it
council.
gone
Or
so
White House
a
long.
bunch of people.
Advisor.
we
Or
almost had a NASA administrator. I mean, there's one kind of in the works at this point.
We've got an acting administrator, right?
Well, I mean, one was brought up
Yeah.
and presented to a bunch of lawmakers and had to answer a bunch of tough questions, but didn't actually get the gig yet. So
One day.
One
One day they'll be
someday, perhaps, when humans are walking on the moon again, NASA will get a new administrator. Afterwards,
Ironic.
irony. All right, number 8. Let's go on with number 8 here. What was it?
That's me.
That's you.
That's me.
A new group of U.S. astronaut
Speaking-
candidates.
Yeah. Speaking of space flights, there was a 2017 class of U.S. astronauts that was selected this year. There's 12 eager men and women who are going to be trained as astronauts and enter into whatever form the U.S. spaceflight program will look like in the next few years. The astronaut candidates, there were over 18,000 applicants
Man.
for this round of astronauts, which is absolutely crazy. I was not one of them. I did not apply to be an astronaut.
Oh,
I don't think I would have met the requirements.
If you ever want to feel really bad about yourself, just sort of read about these astronauts. And one of them, I think, was like a trauma surgeon who then made a career shift to fly combat helicopters in Afghanistan before deciding, I'm going to become an astronaut to just sort of
Yeah,
get that trifecta.
Yeah.
These people are crazy qualified. There's geoscientists, there's all sorts of engineers, there's naval officers, there's Air Force officers, there's pilots, there's like everything.
And they're all like 30. They've all done a million things that you think you couldn't have done possibly in your life by
It's
the
like
age
when
of
you're
30.
pretty proud of your B+ on the exam, and then you find out 5 people in class
great.
that got
Yeah.
straight 100s. And
Yeah, so- So these astronauts might be going to the space station, they might be going to the moon, they might be flying on commercial spacecraft,
they might be going nowhere.
maybe going to Mars, they may be staying
Yeah.
on Earth. Who knows? They're in training. They started training in August down at Johnson Space Center in Houston. They're doing great. And I do have to say one thing is that I know one of the astronaut candidates.
oh, really?
Ooh.
Yeah. Zena Cardman was a Penn State grad student in geoscience. And we were in the astrobiology program together for a few years. Went on our field expedition to Italy to do caving. She's an awesome person. I was super excited when she got picked to be an astronaut. I was like, I know an astronaut. So cool.
That's awesome.
Yeah.
Yeah, I mean, every biography that you read, or even when you talk to them, like they just have this glow about them. They're
Yeah, that's the space radiation.
that could be. That's the ones who haven't, who have already been to space.
Yeah.
Yeah.
Okay, so show of hands or voices. If you could be an astronaut, would you?
Yeah, you have to.
I don't think my family would let me.
No, I don't think I would either.
Too much
I'm
risk.
torn.
Yeah.
I want to go to space, but I want to come back down.
I don't know how you could turn that opportunity down, though, even if it was like super dangerous. Just like
Yeah.
something so few people have ever had the chance to do.
I was reading Endurance by Scott Kelly, and he was mentioning that when you come off of the space station and you land on your Soyuz capsule, there's a moment where you're kind of tumbling through the atmosphere, you're coming through the atmosphere, and the parachute opens up, and you get stopped and sort of flipped around a bunch of times. And most people are just freaked out by it and terrified. And he's like, it's a lot of fun. So I think there is
Sounds like skydiving.
yeah, I think there's like a level of willingness to take on that kind of risk that I can't do it. I've talked to others, yeah, and their feeling is, the test pilots are fine with it, right? The test pilot ones are like, oh yeah, sure, I'm used to that. But the ones who are like scientists, they're like, you're very aware that this machine could kill you. It has killed a bunch of your friends. You never lose sight of the fact that this is a very dangerous machine, and you are risking a lot. So I I'm going to wait till it's a lot safer. I really want to see space. I would love to be in orbit. I want to set foot on the moon. I want to be on Mars. But I also want to return and survive. But,
Fair enough.
But you would, Kimberly? Have you put your name in?
I probably would. If they would let me. I don't think I qualify in terms, I don't think I would meet like the physical requirements of being an astronaut. But I could do that. Okay.
Too short, too tall, or which I think would get rid of Morgan.
I'm too short. And
I'm too tall.
Yeah, Morgan's too tall.
And I have.
I'm too bald.
Yeah. All right, let's move on to the next one. So this is Morgan, number 7.
Yeah.
Organic compounds or hydrogen found on Enceladus.
I think this means we're like 99% of the way to finding life, right?
Yeah. Yeah.
Mm-hmm.
This is basically, it's done. But we have Enceladus, awesome place. Got this geysers of liquid water coming out of a subsurface ocean that at its core might be heated to, relatively not freezing. It's got contact with rock there to generate minerals and other yummy nutrients. The only thing we were missing from the life picture of Enceladus is organic compounds. And we've started to find them. For the first time, telescopic observations from here on Earth detected hydrogen in the gas or in the water coming out of the Enceladasian plumes. And that's not all you need. You also need the carbon and all of that. But this is a big step. And this should really excite us about the possibilities for life on a place like Enceladus.
And I mean, one that we didn't include, so, if you're wondering, is the fact that they also found geysers on Europa, sort of confirmed that the geysers are on Europa as well. And I was actually watching this new documentary last night, The Farthest, which is all about the Voyager spacecraft. It's on Netflix.
I keep meaning to watch that.
I don't know if it's for you guys. I think it's on PBS.
It's on Netflix in the U.S.
Oh, it is. Okay, yeah. And they were talking about the geysers that they found on Triton. And I hadn't even known about that.
Wait, who?
Maybe.
Cool.
Maybe.
Triton and Neptune are just so underrated.
There's those clouds, right?
Black.
There's the cloud-ish things.
Yeah.
Yeah. So there's in a few of the very few Voyager 2 images of the surface of Triton. This is actually a paper written by Carl Sagan after Voyager 2 flew by. You can kind of convince yourself that you can see clouds sort of wafting across the surface of Triton, and maybe could imagine that those were coming from a sort of Enceladus-like geyser situation.
But I think the fact that the hydrogen gas was seen coming out of Enceladus was sort of the most important discovery about this, but really the evidence is really moving towards the fact that all of these ice worlds could very well have oceans to some extent. That what we think of as a habitable world, the Earth in this tiny little part to have water on the surface of the planet, is 1/1000th of the number of worlds that are these ice worlds that are everywhere. That Pluto looks like it has some kind of resurfacing that's going on.
Titan
Eris,
has a subsurface
Sedna,
ocean.
Titan. Yeah, Titan has like the hydrocarbon part, and then
Titan's a double ocean world. There
Yeah.
are 2 different sets of oceans.
Wait, no one told me about this about Titan. So there's a subsurface liquid water,
ocean.
and then
Subsurface water, and then liquid methane lakes and oceans on the top. 2 sets of oceans.
If you can't get excited about all these water worlds in the solar system, I think just imagine the possibilities in the exoplanet world, that there must be potentially habitable places to live all over all the solar systems that we're finding around other stars. And that just exponentially increases the probability that somewhere out there is other living things.
Well, I did a paper. I did an episode. It's going to come out next week for the Guide to Space. And there's this new paper done by Avi Loeb, who is sort of a fairly renowned researcher, and he calculates that there's probably 1,000 times as many water worlds as there are terrestrial planets like Earth, the kinds of places that would be in the habitable zone. And that you could,
Sounds about right.
and that, like, if the sun shut off tomorrow, the oceans would freeze on Earth down to a depth of about 4.5 kilometers. But beneath that, say in the Marianas Trench and stuff, you would actually get life being able to huddle down there and be able to survive for now ever, right? For billions and billions and billions and billions of years. And so you can imagine these worlds that are moons orbiting brown dwarf stars or planets, you know, that are getting this kind of tidal heating, and they've got the ice surrounding them. Like, when you really think about the potential for life out there, it boggles your mind. And yet, how do we find it? How do we detect it? How do we know that it's there?
Well, you gotta have one with a geyser that shoots off its oceans
Or
into
we get a giant
space where you can detect.
So how about this Starshot laser pointed at a moon and melt a hole in the ice?
Mind blown.
Science.
Yeah. Or at least carve our initials.
Right.
Earth was here.
Earth was here.
Earth was here. Well, the geysers are the way. You fly through the geyser with your nose on your spacecraft, and
Your tongue, come on.
Tongue. It's more of a tongue.
it's a tongue. It's like a right.
It's obviously a tongue.
Yeah. And get the sample, taste the ice to find out what's down there. But it's kind of I just find that so crazy that there could be, and each one, like the amount of water on Europa is like 3 times the amount of water that's here on Earth. Like, we're the desert.
Yeah. So speaking of putting space tongues on ice moons, totally sorry, that was a weird sentence I never thought I'd say.
Yeah, your segue is going to be rough, but
No.
We'll work on
make it
that.
happen.
No, this isn't a segue. This is an anecdote
Oh, okay.
related to icy moons. There was a presentation I went to once where the title was something like Europa tastes like a grapefruit margarita. And then he went on to prove that it tastes like a grapefruit margarita because it's salty and it has acidic things and it has like methanol. So it's anyway.
So it's like it's
Grapefruit
alcoholic
margaritas is what
and it's
icy moons
acidic
taste.
and it's salty. That's awesome.
And it's salty.
Yeah.
It's a margarita.
And again, like another quick little rabbit hole.
Anyway.
Just today, NASA announced that one of the missions that they're considering, one is to send a mission to Comet 67P to follow up Rosetta, but the other one, and this has got to be the one they're going to choose, is a nuclear-powered helicopter to Titan.
Yeah.
Like,
This was supposed to be my story
I call
this
it a
week. I had
hopper.
no
That just
idea we were
sounds
doing this
awesome.
top 10 thing.
Yeah.
how
I call it a hopper.
How-
'Cause it lands and then it flies and it hops around.
how is this even a choice?
Well, one of those is like 1,000 times riskier than the other.
Or
And
is it-
so the other one is 1,000 times cooler than the other.
Yeah.
And so they kind of balance each other out.
Yeah, I'm
Choose Titan.
I'm 100% on board for the nuclear-powered helicopter on Titan. 100. If I do get that job as being the NASA administrator, I will just sign that into law right away.
How long did Huygens last on the surface?
Hours.
Hours?
Couple
So
hours.
how long would this nuclear-powered helicopter last?
I mean, they're planning to fly it like hundreds of miles across the atmosphere. So I'm guessing a long time.
It'll have an RTG like Curiosity, right? Like it'll just and the
Yeah,
atmosphere
a smaller version.
is twice as thick. The gravity is a fraction of what it is on Earth. Like, this thing will be able to just go forever. So it's the
Yeah, you
greatest-
could, if you put a wingsuit on, you could fly through the atmosphere of Titan. And so it's like the ideal place to land a flying drone.
Number 5. Kim.
Number
do that.
5. One of my favorite exoplanet systems.
Whoa,
is
did we just skip
gravitational-
Cassini?
Oh, we
Yeah.
did. Number 6. Never mind. Go back.
Oh,
Whoa.
that's
Sorry,
ice
Cassini.
cold.
Oh, well, you know what? I'll switch it around. Number
I thought
6.
we were
is going to be Kimberly's, and that way, no, actually, Morgan's just got everyone.
You're taking Trappist away from me.
Okay, yeah, no, do Trappist. It just switched places because the signs changed.
So because you made a mistake, Trappist is demoted.
That's exactly right. And I will, I need you to cover up for my mistake.
I see. It's really, so really number 6 is the discovery of exoplanets in the TRAPPIST-1 exoplanet system. I'm sorry I got that number wrong before. It's really number 6.
Yeah.
So the TRAPPIST-1 exoplanet system, which is all of like 40 light years away from Earth, has 7 rocky, Earth-sized planets, at least 3 of which are in the habitable zone. And it is by far one of the best exoplanet systems that we could hope to follow up with to search for extrasolar life. So cool. It's also completely revitalized the whole discussion of, can we actually have life around an M-dwarf star? Because these planets orbit an M-dwarf star, and those are typically very hostile and for life. And can we actually have habitable planets around those stars? Who knows? But TRAPPIST got us thinking about it again, and it's so cool.
But didn't we just settle that talking about all those water ice worlds that it doesn't really matter? Who cares? Habitable zones
none of these have this thick ice sheath around the top to protect any of the subsurface.
They could have moons.
They could have moons. We probably will never detect those moons, unfortunately. But it could have moons. I suppose the outer iciest of the planets that are exterior to the habitable zone could have moons, and those moons could have subsurface oceans, and those subsurface oceans could have space whales.
But those outer planets, even though they're icy, they're small, right? Yeah. They're small rocky planets. So the tidal effects of any moons around them are going to be much, much smaller than the tidal effects of the moons around our gas giants. So probably insufficient to drive heating mechanisms, if I'm guessing.
No, you're probably right. Plus, it's very unlikely that the inner ones at least will have any atmospheres. It's possible that all the water has been stripped out of the system from UV radiation from the star, but it's getting us thinking about it again. It's getting us talking about it again there. And it is great timing because we also discovered Proxima b, and that's also around an M-dwarf.
Well, where is your community at now? Your community of planet hunters.
My community of planet hunters.
Where are they at the M-dwarfs? Great for life or terrible for life?
Generally, I see it's great for life if, and those ifs include things like it's a quiet star, there's a magnetic field on the planet, there's extra water, or the star is really old and the planet's formed really late, or something like that. There's lots of caveats that don't completely rule it out, just make it a little bit more challenging.
So even with those caveats, there are so many of these dwarf stars compared to stars that, like our sun, that even if it's disfavorable to make one of these planets habitable, you have so many more extra chances that it might come out a win.
Yeah, there's 1,000, 2,000 M-dwarfs to every sun-like star, something like that. Mm-hmm. And we're finding more and more that they're just as capable of having planets as any other star. So why not?
And the M-dwarfs will last for billions, trillions of years.
Mm-hmm.
So even if life is super slow, it still has a chance. M-dwarf planet.
Could be.
I don't know, tidally locked. I don't like that, though. I don't like that tidal locking.
It's not necessarily tidally locked because there's so many objects in the solar system. In those systems, you can get extra perturbations, right?
Yeah, the inner ones maybe, but they're so close to each other that they all gravitationally interact. They're in a very special resonance that actually makes the system stable for long periods of time, even though everything is so closely packed together. So the outer ones maybe not. They probably have days and nights and seasons and stuff.
But the inner ones are in some, not necessarily tidally locked, but in some sort of resonance like Mercury.
Yeah.
Okay.
And this story definitely broke outside of the standard space news group. And it was interesting as people were starting to kind of wrestle with the distances involved, how far this actually is and what it would actually take to go there. And so a lot of the articles that I saw that were sort of, you know, out there with the normals, were very much about like, here's this place and here's how NASA would go there, but it's super far away. And like the second that they think that maybe you've got this place that's in the habitable zone, the second question is, when can we go and visit and find out if there's aliens there? Oh, we can't.
100,000 years from now.
Yeah, we just can't. So unfortunately.
But luckily, Proxima b is literally 10 times closer.
And still can never get there.
Tell that to the Breakthrough Initiative.
I'll do it.
Yeah.
You can't ever get there.
Okay. Oh.
Thanks, Kraken.
Those poor people. All right, now, next in the line, and totally not switched around by accident by me,
Nope.
is the end of Cassini.
I don't think it's a stretch to say that Cassini has been one of the most successful planetary science missions in history. During this whole last segment, I was sort of trying to make a list in my head. I think you have to put Voyager at the top above absolutely everything else. You know, maybe you have Spirit and Opportunity below that, but I think right underneath that is Cassini, which spent 13 years studying Saturn more extensively than we've ever studied any other world with a single spacecraft. We know just dramatically more about Saturn and its rings and its moons and the space environment that far from the sun than we knew a decade ago. And it doesn't look likely that we're going to see another mission like Cassini in the coming decades. And so this really was the end of the sort of swashbuckling era of space exploration. And I think a lot of us are sad to see that end, because now we're going back to these much more targeted missions where we know something and we're going to sort of use that to find out something else. We're not going somewhere to find a billion new things like Cassini has shown us. And in this last year, it ended with some of its most amazing discoveries, measuring the mass of the rings, taking pictures of some of these really close-in moons that look like flying saucers.
Walnuts.
Just really weird stuff.
Pierogi.
I mean, so I think you kind of hit on something there, Morgan, which was like with the Voyagers and watching that documentary again. Check this out, The Farthest. With the Voyagers, they were seeing these places for the first time. Like the Pioneers had gotten there first, but really the Voyagers brought the view close. They went past those moons with the highest resolution, the closest. They saw Saturn's moons up close. They saw Uranus and Neptune for the only time that's ever been seen. You only get one shot with these great big school bus sized first probes to go out that distance. Cassini was like, now let's, with Galileo and Cassini, it was like, let's go back and now let's get everything. Let's just keep the spacecraft there and just get every single thing that we can. Is it an issue that we've kind of got everything now? Is that why we're not going to see another Cassini?
Well, I think one of the reasons we're not going to see another Cassini is it was huge. It was incredibly expensive, billions of dollars. It employed hundreds of scientists, and it took decades to do. Cassini was designed in the 1980s for launch in the 1990s, and here we are in 2017 talking about its end. And if you want to extend that to the next world out and go to Uranus, a trip that took Cassini 7 years to get from Earth to Saturn could take 15 years to get to Uranus. And now you're starting to really reach the limits of sort of the human lifespan in terms of how you can get scientists in their sort of mid-careers to design something and then survive long enough to play out the science that it takes. And we're going to have to rethink how we do these things. And I think Cassini's representing the last of sort of the original way of doing missions. And there's something really special about that.
Yeah, but I think that's it, that we don't need the Swiss Army knife anymore.
Not at Saturn.
Not at Saturn, not at Jupiter, not, for sure at Uranus and Neptune. Both of those.
Yeah, compare what we know about Jupiter and Saturn to what we know about Uranus and Neptune.
Yeah. And
Yeah, we know nothing.
ridiculous. Yeah.
And we know so much about, say, Mars. But I mean, there's so many targets. But the questions that you're asking now, right? Like we asked this question about Europa. What's under the ice? What's in those plumes? You got to send a very special spacecraft that can answer that question, or a very special spacecraft, perhaps a nuclear-powered helicopter to Titan.
Perhaps, just tossing that out there.
That as an idea. That now you're getting at these very specific questions that you're looking to ask. Curiosity is an example. I mean, it's not orbiting the Martian region with a vast suite of tools for a decade. It's down on the surface of Mars, zapping rocks with its laser.
It's going to cost James Webb money to go to Uranus or Neptune. And we're not going to admit that when they finally decide to do it. But it'll cost James Webb money to go to Uranus or Neptune like we did to Saturn. And we've got to decide, is that worth committing a generation of scientists to exploring? And I would hope the answer is yes.
Yes.
Yeah.
I'm
Yes.
down for it.
Yeah. But see, I have to choose, right? Do I have to... Like, if I had to choose, I would be interested to hear your votes then. Fine.
Well, how about, can we take the Mars 2020 money and do it for something else? Is it too late for that?
It's definitely too late for that. And that wouldn't be enough money, but that would be a good start to the money we needed.
What
Yeah.
about Louvre?
What about it? Don't take that from me.
Why?
What-
That's like 3 telescopes ahead of where we are.
Yeah, but a 18-meter full spectrum telescope? Yes, please.
These are the choices we're going to have to make.
I know. And my
Maybe Canada will do it for us.
human.
Yeah, what
we're
if Canada?
always ready. I've mentioned
they
this
don't
every
even
time.
have
Every time you guys threaten to
their
pull a
theaters.
plug,
Don't expect them to launch something to Uranus and Neptune.
yeah, anytime you guys are ready to pull the plug on some spacecraft and you need someone to just like keep the lights on, we're there. We'll totally do it. But
Like the fixer-uppers of the spacecraft world.
exactly. We'll build an arm. We'll build an amazing arm for it. But I think it is an issue of priorities, and it is this issue of these flagships. But I really like the idea of the infrastructure that's starting to happen at Mars. You've got a couple of spacecraft down on the ground. You've got several spacecraft that are orbiting around from different countries. I mean, the Indians have one, the Europeans have one, the United States has a couple.
The UAE sending one,
Right.
China's sending one.
Yeah, and then same thing
When
with the
are we
moon.
going to send people?
Well, that comes next.
We're not going to talk about that.
But it is really the end of an era. I mean, it really is. Cassini is the final flagship.
I don't think so. What about New Horizons? I know
New
that's
Horizons was a totally different class.
Yeah.
That's very different.
But when you think of this spirit of exploration, I think of New Horizons like a Voyager class mission.
Yeah, absolutely.
A flyby, it's the first discovery, it's the first taste, and it's still trucking.
I mean, I think of Juno as being closer to Cassini type in that it's picked a planet, it's there, it's collecting every gosh darn piece of data it can think of while it can survive.
Juno is like it's like 1/6 of Cassini.
Yeah.
It's like if you took only the magnetic field instruments off of
much
Cassini.
Shorter. Agreed. It's like 4 years it'll be there only. And then
It doesn't really even have a camera. It doesn't.
Cam.
It has like a fake camera.
Yeah.
It's Juno Cam.
It's producing beautiful pictures
We're
with its
learning
fake
things.
camera. Yeah.
And we have magnetometers and particle detectors.
They didn't even want to put the camera on it. NASA Education made them put it on there so that they could do public
Good for
outreach
you,
with
NASA
it.
Education. It's the
Could
best.
you have
Good job.
a sort of standardized spacecraft that you could then send to lots of different places and just kind of mass produce?
That's what Cassini was supposed to be.
Yeah.
It was supposed to
did.
be the first in a new version. Yeah, Cassini's the last Mariner spacecraft, and it was codenamed Mariner Mark II, and it was supposed to be the progenitor of a whole class of orbiters that would be at all the planets. But then it cost billions of dollars,
Right.
and
Oh, yeah.
and
That
we canceled it.
Yeah.
puts a damper on things.
Yeah. All right, let's move on to 20 now successful launches by SpaceX. So,
wow, even more exciting than
reused landings. Sorry, 20
yeah,
landings.
even more exciting than 20 landings is that 2017 was the first time they started launching them again. They did one back in the beginning of the year. I can't remember if it was March or April. And they did maybe even bigger one just a couple weeks ago when they launched to the ISS. So NASA's now flying on these reused rockets, and that's a huge step towards getting, they're the gold standard for evaluating the risk and cost of these things. If they're willing to do that, that's a signal to anybody that this is a thing to do. It went perfectly, it delivered supplies, and that capsule made a second journey through the atmosphere to land on the Earth. And I think in 2018, we're going to see that pace pick up, and many, many launches will be on these reused rockets.
So this latest one was a reuse of the first stage and the capsule?
Right.
Yeah, it was a reuse of the Dragon. So it was a secondhand Dragon and a secondhand rocket.
NASA's running out of money, man. They have to buy secondhand rockets
No,
off
but
eBay.
SpaceX is so far ahead of everyone else with this, aren't they? They're
the only people who can both fly to orbit and reuse their rockets.
Yeah.
A lot of people can do one of those two, but nobody is a year or two away from doing the other.
Yeah.
Yep. But
I
as
mean,
we've
reusing
mentioned in
them-
previous episodes, like Blue Origin is deeply pocketed and run by the richest
Those
person.
Amazon Prime subscriptions.
yeah, they order all their parts through Amazon Prime. So
No, but reusing the rockets makes them much more affordable in the long run, right?
That's the plan, is they could be
That's
a
the
tenth,
hope, yeah.
a tenth the cost, 100th the cost down the line. We'll see Falcon Heavy launch next year. That'll be the first rocket designed from the ground up to be reused.
did you see the
Rocket
picture?
joke.
Awesome.
Musk just tweeted a picture of the Falcon Heavy. It
looks awesome.
Yeah, it looks great. And both of its side rockets are reused previous Falcons. So it's all three parts are going to, return to various landing sites, and the whole, the upper stage isn't going to be reused, but the three bottom stages will all be reused. But Musk is being very cagey about it. Like, if this thing clears the tower and when it explodes and it doesn't cause any damage to the pad, that will be a victory in his mind. So, and
It's exciting times.
And then he's also potentially planning on sending his car to Mars, I think. Which I think is crazy if he does that, because everyone's like, oh, that's so audacious, so brave, Elon Musk. But I'm sure there's a lineup of people that would love to have a satellite with a high chance of being completely destroyed put on the top of that spacecraft and sent to Mars. There's plenty of people.
Why is putting a car on Mars brave?
Cars in orbit around Mars.
Yeah, car in orbit around Mars.
I mean,
forever.
how many cars in orbit around Earth are there?
There are none.
That's right. That's how brave it is.
You make a fair point, Paul
straight to
M.
Mars.
Sutter.
Yep. Yeah. Yeah, it really is. It's just, proving your prowess to the cosmos. Throwing cars into the universe.
It's about the style. It's about the audacity.
Yeah.
That's the boldness. That's the courage. Like taking the headphone jack off of the iPhone.
That's a whole different class.
And the goat is saying in the chat that he was kidding. They did launch cheese for the first Dragon capsule.
What kind of cheese?
He might not do it, but I don't think he was kidding.
Yeah. Exactly.
What kind of cheese? Because I would consider brie a different category of success than a cheddar.
I think it was a block of cheddar, but it was the mass of a human being.
I think Elon Musk has reached that point in terms of financial power and industrial might, and renowned for saying he could just say whatever he wants. He'll just make things up and it becomes true. Oh yeah, we're going to build a moon base using mole people. And and we're like,
Why
okay.
do you think he's got this drilling company?
Yeah.
He's looking for the mole people.
Yeah.
It all fits together.
How's he going to do that?
Well, I mean, I don't think that's entirely true. I mean, Tesla is sort of on shaky financial situation. It's still spending gobs of money. One of the rumors that I'd heard going around was that Tesla and SpaceX might merge at some point, but I don't think that'll happen because he promised us that SpaceX would never go public. So that and Tesla is a public company, so they can't do that. All right, let's move on to the next one. Did we all see the eclipse this year?
No.
Not in totality.
Oh,
I missed
Oh, right, Paul, you got clouded out, didn't you?
Yeah, but Nashville.
I was like 3 miles north of you, and it was great. I'm sorry. I'm not
It's
gonna
the
rub
most
it.
gleeful I've ever seen Kimberly.
yeah.
So cool.
That was a vicious smile.
Yeah.
I am sorry.
You
That
saw
was-
you saw a transit.
I did.
Yeah.
I saw a transit.
An
of a
exo
moon.
moon transit.
Ah, gosh, it was so cool.
Uh,
And so if you didn't see it, you start seeing the disk of the sun getting occulted by the moon, and it sort of looks like a Pac-Man, and then it gets closer and closer, and you're like, crescent sun, when have I ever seen one of those? And then you get totality, and it's like dark outside, and you look up and you see the dark moon, and you see the wispy corona outside the sun, and then it does the whole thing again in reverse. But we're gonna touch that corona pretty soon with the
Oh
solar probe.
Yeah.
That's exactly the thing that we're gonna touch with this solar probe. Was the corona that we saw in the
Is there a
eclipse?
tongue on that?
Taste.
I think all spacecraft have tongues.
Yeah.
Oh, okay. Good to know.
So
I really think the eclipse was like I argue that this was the number one space and astronomy and even science story of the year, just because it had hundreds of millions of people paying attention to it.
Yeah.
And in sheer power of buildup and excitement, and then 24 hours, everyone forgot it even happened. And we went back to our daily lives. But just like that moment, that brief moment that day, like the whole country was united in this spectacular event.
The president was staring at the sun.
Right.
We're all staring at the sun. It was great. And it really is rare. I don't care what Neil Tyson said about it. It was a rare event. And it was a very special event. And I think it was very emotionally powerful and a great way to talk about science and introduce science to a lot of people.
It's what you would have said had you seen it.
Yeah. Instead, what I actually say is, screw you, Nashville, for clouding up.
Yeah.
No, it was
I
like
could have
this,
been somewhere else.
Yeah.
Yeah, it was the single most successful astronomy outreach event in ever.
Yeah. I was in Carbondale, which was at sort of the point of maximum totality. And where we were, this gigantic cloud moved in front of the sun just as it was starting to happen. And we're like, oh, no. And then just in the last maybe 30 seconds or so, it cleared up and we got this perfect view of the sun, and it was great to see. So I got to see the corona, I got to see the final moments of it, and then I saw the beads, and then it sort of went from there. But I'm totally hooked. Like, so it wasn't like what you had, Kimberly, where you got to see the whole thing and it was perfect and you saw the full thing. I got this taste of what it could have been, and so now I'm totally hooked and
So
can't
you're going
wait.
back to Carbondale for 2024?
No, well, yeah, no, not Carbondale. I think
Come
we're
down
gonna
to Texas with me.
Yeah, we're gonna go to
Oh,
Texas.
no.
Yeah,
Fraser and I are going down to South America,
Yeah.
July 2019. We're going to see it in Chile.
yeah.
Cheaters?
Planning a trip there.
Not a
Yeah.
Chile for solar eclipse.
We're gonna
It's-
chase that eclipse around the
Yeah,
world.
it's happening. It's so cool. It's happening in the Elqui Valley, which is a dark sky sanctuary.
Nice.
It's happening right over some major observatories. Pretty great.
You don't need a dark sky observatory
I'm
sanctuary
aware of
for
that
us
phrase.
for
I'm
the
aware
sun.
of that.
Okay.
I'm just pointing out the amazing coincidence that not only
He's just rubbing it in.
an event, you also
Yeah.
get a nighttime event.
Yeah,
know what I mean.
you will be able to see the daytime sky with very
Hey,
little
but
light
during the
You
pollution.
can see
eclipse,
the
you'll be
day
able to see
star.
more stars
Yeah.
in the Elqui Valley than you would have in the United States.
No, and you are going to scout it out in a year from now, I think.
Yeah, so December of 2019, I'm leading a trip to northern Chile, up to Atacama, actually, for a stargazing retreat. And I'm also scouting out the Elqui Valley, looking for some good spots, meeting the people I need to meet to make sure that the Eclipse trip in July of 19 goes off without a hitch.
Yeah, it's gonna
astrotours.co for more info.
Right on.
I gotta ask, is it cheaper if you don't get the M?
The M was not available, Morgan.
Yeah, and was taken.
M was taken.
But
You can also go to astro.tours.
there you go.
How about that?
Dot tours. Wow, I should change.
Yeah, astro.tours.
That's a good name. All right, I get the next one here. So we're going to talk about the interstellar asteroid, which, you know what, I was all over this story. As soon as there was like this discussion was happening over on the Minor Planet Center discussion list, I happened to notice this and wrote a story about the fact that perhaps the first interstellar comet had been discovered, and then over time we discovered that there was more and more going on, and that actually maybe it was an interstellar asteroid, then named Oumuamua, and it is the first asteroid seen on a hyperbolic orbit. So it came from out there, we don't really know where, passed through the solar system, and right now, like just about now, it's pretty much at the dimmest point as it's heading back out. Over the next couple of years, it'll reach the orbit of Saturn and still spend thousands of years inside the solar system until it escapes back out into the larger galaxy. But it's pretty exciting that it's the first interstellar comet, or interstellar asteroid, except now astronomers are saying, well, maybe it's actually not an asteroid, maybe it's actually a comet again, that in fact it's like got some kind of covering outside of it that's like some
Make up your minds, people.
I know, right?
Yeah, what's with these scientists?
Well, and the thing is that there have been hyperbolic comets seen before, right? So then it makes it not the first thing that's seen. But anyway,
But Interstellar.
And the Breakthrough Listen team turned their vast telescope array at it and listened to it and didn't hear any aliens talking on it. So
shocker.
Yeah, so it's not rendezvous
I
with
had my
Rama.
fingers crossed, okay?
Yeah, we all did, of course. But now we're sort of starting to learn that perhaps these things are actually very common. There could be tens of thousands of them passing through the solar system at any time, and it is, you know, one of these things that you sort of, I think, at some point expected to see, but the fact that it has been discovered, the orbit has been confirmed, and I think it's really raised the awareness in the minds of a lot of astronomers that these things are out there. And we talked about a mission on a previous episode that if you could get to one of these things and be able to study it up close, you could unlock just deeper secrets about what it's like for things to be forming in other parts of the galaxy. All we have is the asteroids and comets and stuff that we find here in the solar system, and it all came from the same nursery. So to be able to get our hands on one of these other things would just be amazing.
How great would it be if we could actually like tug this thing into Earth's orbit, do an asteroid capture and study it up close, just have it there.
It's really going fast. Like
You're crushing my dreams.
No, I know.
You're crushing my dreams of capturing an interstellar asteroid as my own personal pet.
The best, I think, the mission that makes sense, of course, as the director of NASA, is an interceptor. So something like what they did with L-Cross or with, what was the one that smashed into the comet?
Impact.
Deep Impact. So send an impactor with a spacecraft with a tongue, and do the impact, collect the debris, and have your spacecraft return back to Earth and tell us what it found. That is something that I think you could have ready to go for when the next interstellar asteroid is on a collision course with the solar system, and then you can try and intercept
and blow it up for good measure.
But even that, well, yeah,
just in case.
But even that's a
we
toughie.
should just make a giant baseball mitt and catch the thing. But
yeah.
What do I know? I'm not the director of NASA like you are, Fraser.
The orbital mechanics to try and capture, if it's big enough that you can spot it far enough away to send your mission, then it's a bad day to try and catch it.
Probably don't want it to come any closer.
You don't want to try and put a spacecraft anywhere near it to catch it.
No.
Yeah. But the idea of moving asteroids is pretty important and something that we should definitely figure out. And it's too bad that got canceled.
Why is moving an asteroid important?
Well, because we're going to want to mine them, of course. But also, you know, if we do find out that an asteroid is in some kind of dangerous orbit, we're going to want to be able to nudge it. We want to know how hard that is to do.
Don't we have math for that?
Very difficult.
Yeah, but it's one thing to have the math, and it's another thing to actually do it in practice.
That's debatable.
Yeah.
There's your last Kraken of the year, going out with a whimper.
Yeah.
Someone made a Twitter post, release the spaceman. That's the thing
Well
now.
done, whoever you were on Twitter.
Yeah, thanks.
Thanks.
Well done.
Nicely done, Twitter. Well played.
So there you go. It's the one
So-
decent thing that happened on Twitter in 2017.
For 2017. Well, Paul, you get the #1 story of the year.
Drum roll.
Kilonova.
Oh, that wasn't a big drum roll.
Yeah.
Oh, sorry. I didn't know there was anything.
That was drum rolling.
Yeah. A little
We
suspense
can do it
here.
again. Let's do it again. Let's do it again.
Okay.
Paul, you get the #1 story of the year, and that is
Kilonova.
Ah, surprise.
That worked out worse. Kilonova, 1,000 times more powerful than a regular nova. A neutron star colliding into another neutron star and blowing up.
And
we
releasing
saw it,
gravitational
and
waves.
it released gravitational waves, and it released electromagnetic waves. We caught all the waves, every one of them, and it was cool. It was great. It was nice. What
That's
else do you want to know? It happened.
well, it's true. I mean, the funny thing is that we have gone over it so much here in the show. I think with a lot of these things, like we're like, didn't we talk about this already?
Yeah.
Yes,
Play down,
we
man.
did.
Yeah. Well,
This is old news.
I'll bet you the next show that we do, we're going to do the what's coming up in 2018, and that's going to be a whole different show because
The year of the space tongue.
we're going to be
We're
so
gonna retire the space whales.
right.
Yes.
And move on to
Well, because
space.
then we're going to be speculating, right, about all this crazy stuff that's going to be happening over the next year and what it's going to mean. But Paul, as someone who I think was part of this, you know, not necessarily the discovery, but in the scientific community, like, did you know that it was happening before it was announced?
Like any one of these big announcements, there's always rumbles, there's always rumors, because someone on one of these collaborations, as they're putting the pieces of evidence together, they start talking, they'll go on some message boards, they'll talk to some colleagues, and you hear kind of through the whisper net that something is afoot. And then by the time they announce the press conference and you see who's on it, you're like, okay, I know what's going on.
But you didn't know specifically what had happened.
I did, actually.
Yeah, okay. That's all you had to say.
Oh, okay.
Yeah.
I
Yeah.
was just trying to be like,
Yeah. No,
Take a step back.
I was genuinely surprised. But, you know, I try not to be part of embargoes, so so I was completely surprised when they made the announcement.
and it was the next thing to announce. Because if you've already got a few gravitational waves under your belt and they're all black holes, and then you make a big deal about gravitational wave discovery, what else is there? Well, it's neutron star mergers.
But it wasn't just the neutron star mergers. It was the combination of the neutron star mergers plus the light source that went along with the gravitational wave source, and the synthesis of all this crazy material, like high element material, and
Yeah, there's a lot of
so much that went with it.
there was so much. What I think is really cool is all the technological framework that had to go into place to make this discovery possible, where it's not just the gravitational wave detectors, it's not just the optical and the radio and all the other observatories around the world that are linked. It's the communication platforms, the alert systems, the rapid response, the follow-ups, where one set of detectors can see something interesting in the sky. And I think this is going to be a trend we're going to see more and more of the coming years. One instrument spots something interesting in the sky, blasts out to the world of astronomers. everyone follows up as quickly as they can, and we gather data for weeks, and we're able to paint this wonderfully full picture of these transient short-term events that we simply couldn't capture prior to these technological revolutions.
4,500 collaborators, I think, on the paper that actually publishes. Like, it's just like it really.
Yeah, it's like all of astronomy.
All of astronomy was involved.
Dude, the shoe just said astronomers of the world.
Yeah, we're involved in this, and I totally agree with you. Right, like I think that was one of the most exciting parts about this whole discovery was the level of collaboration, the number of amazing instruments that were called into play, the techniques they used both to zero in on where the Kilonova happened. They lucked out in getting this detection, not on the I think not on the actual merger between the neutron stars, as you said, but getting the visual confirmation in all these other wavelengths. That
having all the pieces in place that they could follow up quickly. And we're going to see more of that. And I think, not trying to get ahead into our next episode, we're going to see more of that, of this time domain astronomy, of stuff that's happening in the sky right now, observing it with every wavelength and every mode, with neutrinos and with gravitational waves. And just painting a picture of this dynamic, violent universe that we live in.
Do we know, Arjo wants to know, did we know if it turned into a black hole?
I think the estimates are yes.
Yeah, that's what I'd heard as well. Most likely, yes.
It ended up as a black hole.
Yeah, which is pretty cool. All right, so we're going to take a break for the next week. Apparently, there's some kind of holiday coming up. And so we're going to take a break, and then we're going to be back in 2 weeks with in the new year. I guess the first, I don't know what the date is going to be. So not the 27th, but the 3rd.
Oh, wait, no. The
2nd?
December 29th, anyway, we're skipping.
Use your calendars.
January 3rd.
This is your homework. Find out what the next Wednesday is after the Wednesday we're just about to have. And then we're going to do the episode where we're looking to some of the big events that are going to be coming up in 2018. We're going to prepare you emotionally for how your life is going to change when all of these big, cool missions happen. Some of these events may just keep reoccurring, like the Falcon Heavy. We're like, Falcon Heavy's going to launch this year, but others.
That'll be interesting, because then at the end of 2018, we'll look back at the start of 2018, and you can compare what we psyched you up for and how much you were let down.
Well, I'm looking at the list of things that we had for this year. We could have predicted 2 out of the 10, right? The end of Cassini and the Eclipse.
Nobel Prize, that was a given.
Nobel Prize, yeah, no, I don't think I was
all right.
was surprised by that.
And maybe SpaceX. We probably could have predicted the SpaceX. So, all right, cool. Well, we've reached the end of our show. Everybody enjoy your holiday. Kimberly, if people are looking to see some of your work, what should they be? What's something recent that you can shamelessly self-promote?
Oh, so the last one I did was actually about snails again. I went back to snails.
Just can't get enough.
Are you their dedicated snail writer?
I might actually be the dedicated snail person, but I've been politely asked not to write about snails for a little bit. Too many snails, but it's cool. Apparently, if you cook them, you can still take measurements off of them.
Like nifty. How good they taste?
No, like how well they predict weather.
Even though they're
did snails predict weather?
Well,
and cooked snails predict weather as well as uncooked snails.
Reconstruct weather. Anyway,
we're gonna have to read your story.
Super weird.
Yeah, it makes sense.
All right.
It makes sense if you read it, cause writing. And before that, I did a story about fossils, all based on stuff that was presented at the AGU fall meeting last week in New Orleans. So very cool.
How I mentioned that doing an AGU meeting as a journalist was rough. How did that go for you?
It is crazy, Kate.
Yeah.
That is the craziest conference that I've ever been to. Is 25,000 geoscientists running around talking about science. and all the press people running around trying to keep up and
Yes.
failing miserably.
Yeah.
I got
Totally
very
different being a
during the
journalist
week.
than being a participant in the conference,
Yes.
isn't it?
It's very different.
Yeah.
Very, very different. I got very sick at the meeting,
Oh.
keeping up my streak of getting sick at conferences.
Yeah, they call
like
that
I
the
do
con crud.
every year.
Pamela, without fail, will pick up con crud at every convention.
Yeah.
Morgan,
Anyway, but it was a great meeting.
right on. Morgan, what's
That's me.
what's a thing that you just created? Now you didn't even know, but you just wrote a script for a very
Yeah,
entertaining
apparently,
video
yeah.
from SciShow
All
Space.
right, those, and weeks to months later they appear, and I'm slower than you apparently at checking. But actually, the day after Christmas, we are opening at the Fort Worth Museum of Science and History our very first in-house planetarium show production. And so we've
Right on.
been working since March to put together this show. We've had a 3,500 word script out to our staff for a couple of months now, and it is all coming together next week. And I'm excited to find out what it looks like, because it's coming together in so many different pieces that nobody has sat down and seen the whole thing all at once.
I would
Congratulations.
love to make a planetarium show someday.
It's a lot of work.
For sure. We had someone showed me the planetarium. I got a sort of a special tour of a planetarium, and I got to see how the software worked, and I got to sort of play around with that. And also, Paul, when I was there, Pamela and I were there in a couple of years ago. You said, "Oh, and by the way, guys, do a planetarium show," and so we came up with sort of a custom show where we showed off a bunch of interesting photographs.
off
and
the
stuff.
cuff.
Off the cuff, yeah. And it was like, this is super hard and super weird, but boy, I would love to get a chance to take another crack at this with more time as opposed to doing it off the cuff. So
I don't know. Sometimes, I mean, I've done a lot of those off the cuff ones. In some ways, they're kind of more fun because they're so spontaneous.
yeah.
You know, after 9 months, every second of this has been measured and timed and scripted, and I'm ready to move on to another one because I've had my fill of the solar system.
Paul, what's something that you can shamelessly self-promote?
Well, let me see. I've got a YouTube video coming out tomorrow that's a collab with Ethan Siegel. So he'll have an article up on Forbes embedding the video, and then he appears in the video.
Right
We talk
on.
about the first stars in the universe. I have an article that just came out on space.com about what is quantum spin and why it may not be what you think it is based on the name. And of course, astrotours.co. We are currently taking reservations for the cruise that you're coming on in September 2018 and to the Atacama Dark Sky Retreat in December of 2018.
And I'm just going to shamelessly mention that Dave Dickinson, our astronomy writer over on Universe Today, is working hard on the new book, and should have the first draft done by the end of February. And I've been reading it and really enjoying it as it's coming together. And my job is to pick pictures. So I'm reaching out to amateur astronomers and
It's the best
astrophotographers.
job.
I know it is the best job, yeah.
Get to
And
look at awesome astronomy pictures.
well,
all
and the cool part is that I've got this huge community of people over on Instagram who have been running pictures on our channel, and now I get to reach out to them and get them to participate in the book. So there's going to be, hopefully, we're going to have a book filled with pictures that nobody's ever seen before, which I think is pretty exciting. So,
Nice.
yeah. So that's happening, and you'll hear lots more about that as we get closer. All right, well, we've gone way over our time. This doesn't really surprise me, so
Thanks for sticking with us,
Yeah.
viewers.
I'm going to put everyone in the
have
gallery
anyone left?
view.
Anyone?
Yeah, I think there's a few people left. So thanks, everyone, for joining us today. Thanks, as always, to the folks from the WSH crew. Go to wshcrew.space to join that community, and we will see all of you in 2 weeks. Have a great
Bye, everyone.
Next year.
holiday. See you. Have a great
Happy
new year.
holidays.
All right. See you later.